get started. So on Monday, we spoke about hyperbolas, right? Bava went through finding an equation of the, so does anybody have any? Notes in front of you, or if you don't, please go get them. Oh, that's unfortunate. Can everyone else hear me? Maybe it's my connection. I'm hoping everyone else can hear me. Yeah. Okay. So if you look at this hyperbola that we have here, we said that Q was our asymptote. And what is our asymptote according to the graph that is on the screen right now? Remember, the asymptote is the line that your graph is not allowed to cross. It comes very close to it, but it will never, ever cross it. And if you look carefully over here, nice, Saneli. So -1 would be our asymptote. So we can already substitute -1 into the equation of the graph. So I'm going to write this down. So fx is equal to a over x minus 1. What other information have we been given on this graph? If you look at it, we've been given one other piece of information, and that is a point, a coordinate, this one over here. And we've been told that that coordinate is 2, 0. Good afternoon, Moleboge. Good afternoon. All right, so that point we do, but we do not use the y1 because it can't help us at this point, right? So we only need one asymptote. The y1 is 0, which is contained over here, and it doesn't help us at all, right? So there's the one that we filled in, and then we have a point, which they've told us is 2, 0. And just remember, keep in mind that points or coordinates are made from an x and a y. And what do we have that we can substitute in the equation? We have an x and a y. Do you guys agree? Fx is the same as y, and x, which is at the bottom of A, is just x. So let's substitute this point. So I'm going to say 0 is equal to a over x, not x, over 2 minus 1. Now we only have one variable left, which is a at the top, and we can solve for a using the numbers that we have. So first things first, we have to get rid of everything around a, and the first thing is this -1 by taking it over to the other side. So then we're going to have a divided by 2 is equal to, what happens to -1 when it gets to the other side? It becomes a positive 1, right? So a over 2 is equal to 1. Great. Now the only thing left to get rid of here is my divided by 2. And what is my inverse operation for divided by 2? I know we know this, don't be shy. My inverse operation for divided by 2, thank you, Andy. So we have to multiply by 2 on both sides. The 2's are going to cancel out on my left-hand side, so I'll be left with a equals to 1 times 2, which is 2. And then you have all the components you need to find this equation, because then fx is equal to, now we know that a is 2 over x minus 1. Okay, so you just use what you have and substitute. All right, guys. That's all for the while you wait. Now, today we'll be doing exponential graphs, which look an awful lot like the hyperbola. The only thing is, an exponential graph looks like one side of the hyperbola. So for instance, it's either going to be this curve, or it will be the curve that is going downwards, which is this one over here. It's all right. Welcome, Desmarie. All right, so let's check. After this, we need to be able to fill these in. If A is greater than 0, what happens? If A is less than 0, what happens? If A is between 0 and 1, what happens? And if A is between -1 and 0, as well as 0 and -1, and Q. Now, we know something about Q. For all of the graphs that we have done, what does Q do for the graphs? What happens with Q? We just saw it now. If I have a graph and there is a Q value, what does it do to my original graph? It moves it, right? Does it move it vertically or does it move it horizontally? How does a Q move my graph? Let's hear, guys. Does it move it vertically or horizontally? It moves it vertically, right? Up and down. So we already know this because for all of the graphs that we have done, all that Q has ever done is move my graph up or down. Now let's see, let's find out what all of these do for us. The first equation we have is fx is equal to 3 to the power of x plus 1. Now, just like your hyperbola, this graph will have an asymptote. And if the graph has not moved at all, my asymptotes are always x is equal to 0 and y is equal to 0. But if I'm telling you now that Q moves the graph, that means it will also move the asymptote. So if my asymptote was originally x is equal to 0, but now I have an equation that says 3 to the power of x plus 1. That means my asymptote will move 1 unit up. So now this is my new asymptote over here at x is equal to 1. At y is equal to 1, excuse me, y is equal to 1 here. This will be my new asymptote. So we know whatever this graph does, it will not cross this asymptote. It never does, right? So let me write it over here. Y is equal to 1, and we've gotten it from the equation. Now, we just have to sketch this graph, right? And the best way to sketch is to find your intercept. So we have fx is equal to 3 to the power of x plus 1. How do we find intercepts again? How do we find intercepts? Let's hear. We make one of them 0. So if I want to know where this graph is going to cross my y-axis, which one do I make 0? Is it x or is it y? Is it x or y? I'm going to have to make my x 0. So I want to know my y-intercepts, which means x is 0. Now let's get working. That means y is equal to 3 to the power of 0 plus 1. What is anything to the power of 0? Anything to the power of 0 will give me, it'll give me a 1, right? Plus the other one, that means my y-intercept is at y is equal to 2. So that is over here. Okay. Now, the first thing we're going to learn is if a is greater than 0, then your exponential graph will curve upwards. Will curve up. I know you're probably thinking, what do you mean it curves upwards? I will go to the side now and show you what I mean. Okay, this is what I mean. So we have two different types of curves, right? One that curves upwards like so, and then one that curves downwards like so. So this is what I mean when I say that your graph will curve upwards if a is greater than 0, excuse me, if it is a positive a. All right, so now let's look. We have an A that is positive, and we know that it is going to pass Y. Maybe I should write this point here. This was 1. This is 2. It's going to pass the Y-intercept at the Y-axis at 2. Is it allowed to touch this asymptote? Is my graph allowed to touch my asymptote? No, it isn't. Right. So if it curves upwards, then that means it's going to go all the way from here and all the way up that way. And that is your sketch for the first graph. Do you see that these are the easiest ones to sketch? And the reason it starts escalating so much is because of purely the fact that it is an exponential graph. What happens when you put exponents on numbers? Look here. 2 to the power of 2 is just 4. But as soon as you say 2 to the power of 3, it has now doubled to 8. Do you see how quickly these points are actually increasing? 2 to the power of 4 is now 16. So if you had to plot this, the first point would be at 4. Then you have to go all the way up to 8. Then you have to go. So my curve would have to go fast, would go up very fast. Okay. So the bigger your base, the quicker it curves, or the steeper your graph, because it curves quickly. All right. Before I move on to the next one, do you guys understand the curve? The first one. Are we good with that one? So we've established if A is greater than 0, then the graph will curve up, which means if A is less than 0, then the graph will curve down. All right, we'll get to the fractions just now. Let's look at the next one. It says g of x is equal to -2 times 2 to the power of x. Firstly, what is my asymptote for this graph? Let's start there. What is my asymptote for this graph? Do we have a Q value is my question. Do we have a Q value for this first one? Think of the Q value. Let me go up. The Q value is usually after this, like it's a -5 or +2 or something. So do we have a Q value for g of x? No, we don't. So that means my asymptote has not moved. And if it hasn't moved, then the asymptote is still on the line y is equal to 0. Now, because this is already in black, I'm going to highlight it in green to show you where it is. Here it is over here. Okay. So my asymptote has not moved. Now let's look for my y-intercept where x is 0. X is equal to 0. All right. So then this will say y is equal to -2 times 2 to the power of 0. And once again, anything to the power of 0 is going to be 1. So this is just -2 times 1, which is -2. So my y-intercept for this one is, I'm going to put 1 over there, -1, -1 here, and -2 here. So then my intercept for my y in this case is a -2. All right. Now we spoke about if A is positive and if A is negative. In this case, is A positive or negative? Look at the general formula over here. And then look at g of x. And tell me if A is positive or if A is negative. A is negative, which means what? Which means what, guys? It curves down. So it starts off there and it goes that way. It's not the best graph, but it's a curve. You guys get the point. Nice, Palisa. Thank you. All right, are we with me on the second one? Are our rules making sense? Hopefully they are. Okay, now let's speak about when x is, and this why you're saying a bit. What can I clarify a little bit for you here? Is there anything I can clarify for you? Okay, you'll tell me. Okay, that's fine. That's fine. If you need more practice, then it's fine. Remember in grade 10, you don't go into too much detail with this. You just need to know the effects of A and Q. All right. Now, if A is between 0 and 1, which means it's a fraction, that's what we have here with hx. Do you see that? 1 over 3 is between 0 and 1. The graph will still curve up, but something else happens with it. Will curve up, but it is reflected on the y-axis. So this is what I mean. So this was my original curve up, right? Now, if you have a fraction, it will go that way. So it's still a curve up, if you can see it. I drew it terribly because I started at the top. But if you look here, nope, I should have just started at the top and left it. If you look that way, this is for A is positive, and this is if A is between 0 and 1. All right. So let's get our intercept. Firstly, do we have a Q value? As in, did my asymptote move for the h of x? Let's hear. Did my asymptote for h of x move? No, it didn't, right? It didn't, because we do not have a Q value. If you look here, there is no +1 or minus something. So this asymptote is still at, okay, I'm going to try and draw it in between now, and you must just remember which asymptote was referring to what. All right. Firstly, don't get into the habit I have now. Please label your graphs, otherwise you start getting confused. This was f of x. My second one was g of x. And the third one now is h of x. So we know that my asymptote hasn't moved, so it's all the way at the bottom here. Maybe I should draw it in a different color so you can see it. And now let's find our intercept. So it says h of x is equal to 1/3 of x. So h of x is equal to 1/3 of x. And if I make x 0, so if I say my y-intercept x is 0, then what is my y-intercept? You guys should be able to do this fast. We'll say y is equal to 1/3 to the power of x. I mean, to the power of 0. 0. And anything to the power of 0, we said is a 1. All right, so we know that for this graph, my intercept, I'm going to draw it in red so that we can distinguish them. My intercept is over there at 1. And that means that my graph goes like so. Now let's hope it takes only one attempt. No, it doesn't. There we go. You guys can just use your imagination. And this one is h of x. Okay. So I want to ask you guys, what do you think happens if A is between -1 and 0? So we've done greater than 0, less than 0, between 0 and 1, and between -1 and 0. Remember, anything between -1 and 0 is a negative fraction. Okay, that should give you a clue about what's going to happen. This is a negative fraction. Let me write it in brackets. Fraction. Let's start with, do you think it will curve up or down? Since it is negative, do you think it will curve up or down? Let's hear. It will curve down. Thank you very much. It will curve down, but it will also be reflected. Now, I know we're very tempted to say it's going to be reflected in the x-axis, but it won't. It's still reflected in the y-axis. Okay, so then graph curves down, but reflected. And I know we don't have a question about that, so I'm just going to draw one to show you where it would be. So instead of going that way, it would go that way. All right, guys, does this make sense to us? Can I have a thumbs up, thumbs down on these concepts? As long as you understand this, you will be able to draw or sketch these graphs. Can I have a thumbs up, thumbs down? A thumbs up or a thumbs down? I see downs in the chat, and I'm hoping that was just for the curve down. Oh, okay. Whew. For a moment, I'm like, what? So many thumbs down. Come on, guys. There's 7 of you in here. I need more thumbs down than 1 or 2 or 3. There we go. 1, 2, 3, 4. All right. That's better than nothing. All right. So we're good. Let's see. I'm hoping this is getting clearer and clearer. All you need to know is the summary. Okay. A greater than 0, graph curves up. A less than 0, graph curves down. If it's between 0 and 1, it will still curve up, but the other direction. And if it is between -1 and 0, it will still curve down, but in the other direction. And then Q has not changed for all of the graphs that we have done. Plus Q or minus Q moves the graph up or down. All right. Great. Now let's see. Okay. Now we have 2 more graphs. All right. I have an fx is equal to 5 to the power of x plus 1. Let me zoom in because I can't see now. There we go. Now I look like I wrote very, very huge handwriting, but it's fine. So remember, I'm not sure why I wrote my plus 1 in my exponent because it isn't in the exponent. Let's start with our asymptote, guys. What is our asymptote for this graph? What is our asymptote for this graph? It is a 1. So that means the graph moved. Did it move up or down? It moved up once. Nice. We're getting this. Okay, let me label my axis. This is Y. This is X. Bloop. And bloop. Great. So here where we have Y is 1 is where my asymptote is. And I'm going to draw it in a different color. Otherwise, we get confused. So when you sketch this graph, just first identify your asymptote, right? And then you look at A. Is A positive, negative, a fraction, or a negative fraction? In this case, is A positive or is it negative? Is it a fraction or is it negative or fraction? What is A in this case, guys? It is positive and it's a whole number. So does that mean my graph will curve up or will it curve down? Will my graph curve up or will it curve down? Nice. See, we're getting it. So you already know in your mind that the shape of this graph is like so. Okay. The only thing you need to now determine is where it's going to cross the y-axis. It will not even cross. Guys, let me actually ask this. Why do we not even bother finding the x-intercept? Let's start there. Why do we not bother so far? Why have we not looked for the x-intercept in this case? Let's see if anyone can think of a reason why we haven't even looked for the x-intercept in this case. Because there is no x-intercept. Thank you, doesn't even pass the x-axis. For these 2 graphs that didn't have Q, I said my asymptote is always the x-axis, and an asymptote means you're not even going to touch the x-axis. We haven't had a graph move down, have we? Not yet. Okay, and then for this one, you know it definitely doesn't pass the x-axis because the asymptote is even higher than the x-axis. Do you guys see? So you guys must make those decisions when you see graphs. And that is why Teacher Coco, I'm assuming, wrote asymptotes and quadrants. So for asymptotes, if you do not have a Q, asymptotes, if you do not have a Q, so I'm going to say no Q means x-axis is the asymptote. Okay. And if you do have a Q, then that Q will be your asymptote. Okay. So otherwise, Q is your asymptote. All right. Great. Now let's look for my y-intercept over here. So that means x is 0. So let me write it properly and start taking shortcuts. Y-intercept, x is 0. So then y is equal to 5 to the power of 0 plus 1. Once again, 5 to the power of 0 is 1 plus 1 is equal to 2. So once again, my asymptote is at 1 and my intercept will be at 2. Okay. Now we have kind of a little bit spoken about this, but the bigger this number, the steeper it is, which makes sense, right? Because 5 to the power of 1 is just 5. But 5 to the power of 2 will now become 25. Do you see how big the difference in these points are? Because the first one will be 1, 5, and the second one will be 225. Do you guys see the point? And the third one will be 3, 125. So this is a very, very steep graph. What does steep mean? What does steep mean? Let me draw 2 graphs and see if you guys can tell me which one is steep. That's graph number 1, and this is graph number 2. Between graph 1 and 2, which one would you say is steep? It is 2 because it increases fast, right? If it is not steep, then it takes a while. It still takes its time, but a steep graph will immediately just go up. All right. So now we have quite a big base here, which is 5. It might not seem big, but if you start adding exponents to it, you see how quickly this graph increases. Right. So now let me try and draw this graph. We said it curves upwards, which means it starts from here. So immediately it's just going to go whoop, and up it goes. And here it gets closer and closer to my asymptote, but it never, ever touches it. Are you with me, guys? Steepness is important because if your teacher gives you, maybe they give you examples of graphs and you have to identify them. The best way to do it, because as you can see, these graphs look very similar, hey? Look at the first one we did. Look at the second one we did. They look very, 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 very similar. So the best way to identify is to look at the steepness. The one that increases the fastest, that means it is very steep. All right. Now let's look at g of x. Firstly, what is a for g of x? Is it positive or negative? Is a positive or is a negative? Is a positive or is a negative? It is negative. So does it curve up or curve down? It curves down. So we already know that it is a down curve. Let me look for space here. It is a down curve. All right. Now, let's look for my asymptote. What is my asymptote for g of x? Once again, I'm not labeling my graphs. This is a terrible habit. F of x. My asymptote for g of x, nice and nearly so, it is -3. So if I have maybe -1 there, -2 there, and -3. So my asymptote is all the way down here. Now, we have a graph that has a -3. Will this graph have an x-intercept? Let me see what you guys think. Will this graph have an x-intercept? There's a lot to consider here. Will this graph have an x-intercept? Because we have now moved it down. If we move this one down, it would have an x-intercept, right? Definitely, because it would be all the way down here and going up. But you are right, Andiswa, but why do you not think this graph will have an x-intercept? You are correct. I just want to hear like your train of thought why you think it wouldn't have an x-intercept. That's because, does this graph curve up, guys? Is it going to go from here up? No, we have just established that it curves down. So how will it have an x-intercept? It can't. Right, so let's get going with our y-intercept. Y is equal to negative x minus 3. So if I make x 0, this will be negative a half to the power of 0 minus 3, which is equal to -1 minus 3. And what is -1 minus 3? This is in my way. -1 minus 3. That is equal to -4, which is my intercept. Okay, now if you are confused about why this negative was not included in this calculation, do you see that this negative was outside my bracket? So it is not involved with the 0. What I mean is, this is different from that. Do you guys realize that? Does it make sense to us? Here, my negative is contained inside the bracket, so the whole thing is equal to 1. But here, my negative is outside, so I have to just rewrite it negative. It's actually -1. And then this, only the bracket will be 1. So those are two separate answers, okay? All right, so we've established -4, that my intercept, let me use red, is at -4. And we said this graph is curving down. So it goes from there, that way, and that was terrible. That way, we have established that I can't draw graphs going down, ne? That way. You guys get the point. But on this side, it must be getting closer and closer to your asymptote. So like so, that's better. All right, guys, I'm hoping you guys feel a little bit better now after we do this. Okay. Now, when we speak about quadrants, right? Quadrants, we said if your graph has a positive a, whether it's a fraction or it is a whole number, but it is positive, then it is in quadrants 1 and 2. Just to remind us how we number quadrants again, this is the first one, second one, third one, and fourth one. So positive a, regardless of what it is, even if it's a fraction, quadrants 1 and 2, and negative a is quadrants 3 and 4. All right. Are we feeling a bit better about this? Can you have a thumbs up, thumbs down? Give me some feedback in the chat. I think after those two examples, we should be feeling better. Wonderful. All right. So as soon as you know any effect, you know how to sketch a graph. The nice thing is they said sketch a graph. What's the difference between draw a graph and sketch a graph? I feel like drawing might be easier though, because drawing means you must fill in every single little coordinate, and it's not to scale. That's true, Andiswa. And if they say draw A, it has to be in scale, and B, you have to go and say X is 1, X is 0, X is -1, and then find points for each of those and plot them and correctly draw that graph. Okay. So with a sketch, as long as you know your asymptote, you know your intercept, you know your shape, then you can sketch the graph. Once again, this is g of x. All right, guys. Okay, now let's see here. We have to find the equations of these following graphs. Now, this is not as bad as it seems because we have to use information given to us through the sketch, right? So let's look at the first one. We've been given that f of x is equal to a times 2 to the power of x plus q. Now, the information given to us is a y-intercept as well as your asymptote. And where can I fill in the asymptote? Let's start with that. Where on my equation can I fill in my asymptote? I can fill it in at cube. So then I can start off by saying f of x is equal to a times 2 to the power of x minus 8. And that's my q filled in. I don't know why my pen is suddenly so thin. That's better. A times 2 to the power of x minus 8. Great. Now we've been given our y-intercept, right? So what do we do with that y-intercept? That y-intercept is actually a point, and the point is 0, -4. So we have essentially been given an x value, which is 0, and a y value, which is -4. So you can go to your equation. Obviously, your x, you're going to fill in where you see an x. Where will I fill in my y value, my -4? Where does that go into my equation? Where does that go into my equation? Where does -4 go into the equation, guys? Exponential. It goes into my fx. You guys know that fx and y are the same thing, right? Here. You need to know that. All right. It's okay, Andy Swad. I'm glad that you tried. I'm glad that you tried, okay? Now, let's fill this in. So then -4 will be equal to a times 2 to the power of 0 minus 8. What is 2 to the power of 0? -4 equals a times 2 to the power of 0. It's 1. So it's times 1 minus 8. Great. Now I want to get a on its own. So what do I first get rid of? What do I first get rid of? Not the 1. Oh, Andis was answering before. I get rid of this -8. And what happens with -8 if I take it over to the next side? Well, to the other side. What happens when I take 8 to the other side? It becomes positive. So I have -4 plus 8 is equal to 8 times 1 is just 8. So then what is -4 plus 8? -4 plus 8. That is equal to +4. So then my equation will be f of x is equal to a, which is 4, times 2 to the power of x minus 8. Okay, are we happy? Can I have a thumbs up or a thumbs down? Thumbs up. Nice, molebogeng. Okay. Jeez. Okay. All right. So this one we have not done. Let's do this one. Okay. I want you guys to try this one on your own. I'm going to give you 2 minutes, which is all I think you need to try it on your own. And then I'm going to be taking answers. So if you find the equation of this graph, will you please send it in the chat? You can DM me if you're not sure, if you're shy or whatever it is. But please try this on your own and then send it to me. 2 minutes. We have just under a minute left and nobody has sent anything yet, so I'm a bit nervous. Remember, if you have an answer, please send it. Okay, nobody has said anything, so I guess we're doing it together. What is the first thing that you guys filled in on your equation? Fx, I'm just rewriting the equation here. Is a times 2 to the power of x plus q. Is the q, and what is my q for this case? What is my q for this case? It is negative. We're doing this one. This one. So it's not -1. Look carefully. The q is, it's okay. It's okay. It's -4. If x equals a times 2 to the power of x minus 4. Great. Now, what's the next thing you're going to fill in? We filled in the asymptotes. What is the next thing we're going to fill in? Nice. The x and the y. So this point over here, which is my y-intercept, I know if it's a y-intercept, then x is 0, and my y is -3. Once again, where do I fill in the y in the equation? Where do I fill in y in the equation? You fill it in at the FX. Good. I see you in the DM. So I have negative 3 is equal to a times 2 to the power of 0 minus 4. Once again, you take your negative 4 over to the other side. So then you have negative 3 plus 4 is equal to a times 1, which is just a. Okay, how much is negative 3 plus 4? Thank you. I almost wrote negative 1 for some reason. 1 is equal to a. Therefore, my equation is, let me move to the side a little bit. F of x is equal to 1, so just 2 to the power of x minus 4. How many of us got it correct? Anybody, somebody, everyone? Nice, Molebocheng and Desmarie. Beautiful, guys.